Alright, good morning all, let's get started. So, yesterday we looked at calculating the area for different shapes, and one of the shapes we looked at was the triangle. Now the triangle we found was quite easy to calculate the area of if we had the base and the height. However, today we're looking at the case where we don't have the height. So, what happens when we get rid of the height? Can you all please write Heron's formula at the top, and we'll continue on to explain it. Now, Heron was a mathematician who lived in the 1st century AD in Alexandria, so this formula is very, very old. And Jade looks like she cares hugely about that. But what it lets us do is, if we have a triangle where we know the sides, say 7, 5 and 4, clearly my triangle isn't to scale, but we don't know the vertical height, so we don't know this measurement here. It lets us calculate the area of a triangle without knowing that measurement. Unfortunately, the formula, or where the formula comes from, is beyond the scope of the course, so I can't show you all the steps to get to the formula. It's not simple, or I would. But what we do is we label the sides of the triangle A, B and C. It doesn't matter which side is labelled what. We can label the smallest side C if we want, or the largest. And then we calculate something called the semi-perimeter, which is written as S equals A plus B plus C, all divided by 2. Once we have that semi-perimeter, our area is given by the square root of S bracket S take A, so that's one of the sides, S take B, S take C, and that's all under the square root. Some of you may have seen this before in past years, is that right? Yeah. Excellent. So nothing too new then. Right. Let's do an example. Someone give... Sorry, I'll bring it back up. There?
Are you recording again?
Yep.
Whoops.
No, it's fine. You're allowed to talk and act like it's a normal class. It just has to be recorded so that the 3 people who are away today can watch it on YouTube.
Listen to YouTube, I'll subscribe to you. Yeah,
Look,
what's your YouTube thing again?
Mr. Budenberg.
Original.
Yes, yeah, I thought so too.
That's just a way.
Right, so let's give us some sides. Carla, do you want to give us a side?
12.
Lovely. Okay, choose a small one.
Is your name Nikki? Your name's Cribble.
And Jack? Lovely. So, our first step. What's up first, Jade?
The S equals.
S equals, lovely. So, we write S equals A plus B plus C. Nikki's right, we should actually label the sides.
Doesn't matter how you label.
Doesn't matter how you label them. All over 2. Then we substitute our numbers into this formula. So A is 4, plus B, which is 12, plus C, which is 7, all over 2. Gives us 23 on 2. Which is 11.5. Alright, Nikki, what's up next now we found S?
You have to do the area equals and the square root.
Good. Area equals square root S bracket S take A, S take B. Yes, I'd like you to write the formula down first, because in your folio task it makes it extremely clear what you're doing, and same with the tests. So for example, if you write down the formula you're going to use but accidentally put in the wrong number, or put in the wrong number when you're entering the calculator, as long as you've been very clear what you're trying to do and it's correct, then we can give you most of the marks. If you just present an answer, then it's very difficult to give you marks. So yes, I would like you to write the formula down before you use it, and it does help when you start substituting the numbers in. So we have square root of 11.5 bracket 11.5 minus A, 11.5 minus B, something's gone wrong here. I know what's gone wrong. You guys have chosen an impossible triangle to do.
Why?
Good question.
Oh, it's bigger than 11.5.
Yes, so that would make a negative under the square root, which should ring alarm bells. So here,
Oh yeah, I've got
our 11.5 take 12. That shouldn't be negative, because if we square root a negative answer, it gets us an imaginary number. And the reason it's that, if you have one side of 7 and another side of 4, how do those two sides go together to line up with another side of 12? Alright.
Don't write this down, or do?
No, do, but we'll just change one of the numbers in a second. See, if that's 7, and that's 4, we know that even on a straight line, 7 plus 4 equals 11. So if that was 7 and that was 4, we still wouldn't get all the way to 12, would we? So we've chosen an impossible triangle. That's okay. Just change the 4 to a 6, and now it becomes a possible triangle. So yeah, it'll take recalculation.
You chose 4. What are you talking about? I chose 12. Yeah, and then you said 4. But you said you still said 4.
Really, it should be my fault for letting you choose those numbers. Having a good day today. No, I don't think I am either.
That was sarcasm.
Really?
So, has anyone entered that in their calculator? What'd you get?
14.9.
Same here. Right. And that's solution for herons. What I'd like you to do now is in the next 20 minutes do those 3 questions, because we actually have a lot more surface area material to get on with this lesson, but those 3 should only take about 20 minutes so we can move on. Alright, so could you all please write surface area at the top and then give your best attempt at drawing a rectangular prism like I've done underneath, please.
terrible.
Oh, it would
Huh?
Sounds like color like that. When you go to
I'll leave them there. Nice one. Alright. So what do we actually mean by surface area, and how is it different to volume?
surface area is
No, keep going.
like much surface it takes.
How much surface it takes up? Yeah. Or how much surface there is. The way I like to think about it is, imagine painting the box is how much of it you would need to paint. So we're not looking at filling it with paint. We simply want to calculate the areas of all its sides. Now, when we do questions, the questions will specify whether we want a full box, so the box with a lid or box without a lid. But either way, our first step to calculating the surface area is the same. We draw at what's called a net. So, step one, nets are confusing. Yeah?
Go throughout the steps. It's like the layout.
Yeah. So,
Cut it up.
remember in primary school how you used to cut out things from a sheet of paper and then fold it up to make a box? What you cut out from the sheet of paper was called a net.
Go throughout these steps.
No, just step one, draw a net. Now, drawing nets takes a fair bit of skill. If I were you, I'd start with the bottom of the rectangle. So, bottom of the rectangular prism. And as you go, it can help to draw in the dimensions. So that we know is L and the base is B. Alright, now imagine... Huh? Yeah, I'll draw this one first, and in fact underneath it I have a proper one because my drawing's not very good.
I'm just googling one.
Imagine we wanted that side there. Where would that go in our net?
The B is.
Where the B is, yes. So we have another rectangle coming out here. And what is the length, this length here? What is that length there?
Is it the height?
Yes, it's the height, good. So when we fold that up, it becomes the end of our box. Okay. Now what about this side here?
It goes above it.
Yep, so if we were going to fold it down and squash the box, that would go there. And I'm sorry, I can't use a ruler here, so it has come out extremely messy. And the height, once again, would be the same height. So these two are the same. And then this here is the length also. Yeah,
Do you have a French drawer?
yeah, I think so. We'll find out. And we keep unfolding it. So if we had a look at this end one here, this end one would go on the end. And once again, its width would be B and the height would be H. And we're still missing the top and one other side, aren't we? We're missing this near side to us, which is very hard to colour in because it's not actually a wall. That near side, and then we're missing the base.
So we could do two more rectangles.
Two more rectangle thingies, exactly. The first one has a height of H, exactly like on the other side, and the other is bigger, because the other is the lid, and even by looking at this we can tell that the lid is bigger than the walls. So what would this length here be? The one I've highlighted on the right. Imagine that was a lid folding over. Its length would still be the same length as the box, but its width would be B, because it has to fold onto the top there. Okay. Now I'll scroll down to show you a nicely drawn out net. Bottom left is a nicely drawn out net, but do you all see the similarities between the two?
They're all the same size.
Yeah.
Not bigger.
They're drawn the same size, yes, they're just not to scale. But you see how the measurements are different? Here, and if you look at the board, you see how that H is different to the base? And it's B because that becomes the lid and folds over to form the lid of the object. It's drawn similarly, but it's not drawn to scale. Now, with all surface area questions, the trick is being able to draw an accurate net, because when you've broken down that prism into its individual squares and rectangles, it becomes very easy to calculate the surface area of all the squares and rectangles. And it pays to read the question, because if the question asked us for not the lid, so just the sides and the base, then we wouldn't be drawing this side here. That side would become superfluous, because that's the lid.
So we always have to draw a net.
Yes, yeah. So in the book, quite often they will give you the picture of the three-dimensional shape and ask you to find the surface area, and I would like you to draw down the net. Yeah?
Can we Google one in case we don't want to draw?
You can Google one to help with your notes, sure, but in the test you'll be expected to draw it, so it's worth practicing. Maybe, yeah?
How do you draw a net of like a cylinder?
Good question.
Cylinder with like a kind.
We're coming down to that. We'll get there in a second. Alright, there's an example of a triangular prism. So these might be the sort of things that you take in your cheat sheet.
Do we have that down?
Huh? You don't have to copy it down, no.
Can I?
You can if you want to, certainly. Do you want me to give you time to copy? Alright, I'll give you some time. Pause. Alright, so what if we wanted to calculate the surface area from that net? A nice systematic way of going about this is to label each individual shape in the net. So say for example we label them 1, 2, 3, 4, and that one can be 5. Alright. Now, for shape number 1, how do we calculate its area? What sort of shape is it to start?
Rectangle.
Rectangle. So rectangle is length times width. In our case, it is the H, capital H, times S. Now, we can see that 3 is the same as H and S. Yeah? It has the same dimensions and is the same rectangle. So 3 also equals HS. What about number 2? What do we do for number 2? Is it?
It's H times B.
Yeah, good, because careful of that B there. H times B. And 4. 4 is a triangle, right? So we're looking for a half base times height. And in our terms, it's perhaps simpler to look over here on the left to see that triangle there. They've already labelled it B and H for us, so the area is just a half base times height. And there's 2 of them, right? Because on each end there's a triangle and the triangles are identical. So our fifth shape,
It's in the triangle on the right.
triangle number 4 is there.
What's the fifth shape? The other triangle.
The other triangle.
Isn't there 2 triangles?
There are.
Fine, it's times by 2.
You can, yes. I like labelling every single shape, so I'll make sure I don't miss one. But you're right, if you can spot that both triangles are identical, you can write number 2 and then, triangle number 4, and then you have to remember to times it by 2. The other way to do it would be simply calculate the area for triangle number 5. Again, a half base times height, and then just add both of them together. See, what you'll get using this, if we label all the sides, is a whole series of final numbers. These would be numbers. And then you just add them up to get the surface area. Alright, now you were asking how we would choose or draw a net for different shapes. Below I've got some examples of other shapes. So for example, the cylinder. Yeah. Is made up of a rectangle and 2 circles. And the really important thing to notice is that if the cylinder's radius is given as r, there, how do we find the perimeter of a circle? perimeter equals 2 pi r. And we did that from our perimeter last lesson, or the lesson before. And that perimeter becomes this length here, becomes one of the dimensions of the rectangle. Because when this net is folded back up again to form the three-dimensional shape, that rectangle wraps its entire way around the cylinder, or entire way around the circle. Can you imagine that sort of happening?
Yeah.
That rectangle will wrap, which means the length of that rectangle becomes the perimeter or circumference of the circle. Now here I've given you the formula for finding the surface area already. Surface area can be found by doing 2 times pi r squared, and each of those pi r squares is one of the circles. So that there's pi r squared, and that's pi r squared, making 2 pi r squared. And then we have 2 pi r multiplied by h, giving us the area of the rectangle. And I'm just having fun colouring it.
So what is it? 2 pi.
That is the surface area equation.
I can't read it.
It's alright.
I can't even see it.
I'll try and make that bigger. We should just... Oh, I've forgotten. I can't do
Read
it.
it out.
Yeah. Surface area is 2 pi r squared plus 2 pi r h.
Do you like doing this? You don't have to write on the whiteboard.
No, I'm doing it so it can be recorded. I prefer writing up on the whiteboard, but then there are 3 people here who wouldn't be able to see it.
Yeah.
And I think I can explain more easily on the whiteboard because you can actually, gesticulate. So point to things.
Is that a plus in between?
Yeah, it's a plus.
I don't know.
And I'm sorry this is a bit frustrating at the moment, but I will get better at presenting via this thing. If that makes sense. Alright. Whoa, what happened there? So, can you go to page 123 and just question 2 and 3? You'll need to draw a net for each. The nets don't have to be